Hi, I'm Adolph Oliver, and in this topic we're going to introduce you to the percent formula. This actually makes working with percent problems easy. It does a fine job with the direct translation ones as well, but we're going to show you its use in things that are more complicated. Here's the idea. The basic formula is A equals P times B. The P and the B are next to each other, so that of course means multiply. You do have to know this original A equals P times B. Now, here's what the three different letters are. Okay, the P is the percent. Okay, that's what has the percent sign, or they say the word percent in the word problem. The B over here is the base. It's the original or starting value, what you had to know first. And the A here is simply the amount that you get. Now, the key to making this work is to be able to identify in the problem what these three letters are. We'll be given two in the problem, and the third one that's missing will be the one that we're solving for, and the missing one can be any one of these three. Well, here's the idea. You always want to identify these letters in the following order. You look for the percent first. The reason, it's the easiest one to find. It either has a percent sign with it or it says percent. Okay, after that you identify what the base is. Now this is the critical distinction between the base and the amount, and this is what direct translation doesn't do for you in more complicated percent problems, but here we'll see it's easy to tell. The base again is the original or starting value, the thing you had to know first. That's the base, and then the A is the amount that you get. Now by the way, the amount that you get could be more than what you start with or could be less than what you start with. Remember, if you want 200% of the base, that means you get twice of what you started with. If you only want 50% of the base, that means you get half of what you started with. So the A here can be larger or smaller than the base depending on what the percent is. Okay, now, as I mentioned to you, what's going to happen in this is the problems will give us two of these and we have to solve for the third. That means we'll often have to rearrange the percent formula, and it has three forms to it. Okay, let's indicate to you how we can do this. There's a nice little trick being able to get all three forms of this. You have to remember, of course, the original one. A equals P times B. Now, if you remember that, you can make yourself a triangle. That's what I'm going to do right here. Okay, here comes our triangle. And you put a T in the middle of it here. Here it is. That divides it up into three parts. So here's our triangle with the T in the middle of it. Now you simply do this. You put the A on top and the two guys on the right side, the P and B, on the bottom. So here it is, A, P, and B. Now, here's how you make use of this. The three forms will be solving for A equals, solving for P equals, and solving for B equals. Here's how you can make this little triangle work for you. Cover up the letter you're solving for. Okay, let's say I cover up the A here. So I'm going to have A equals, well, see what we've got here? P and B next to each other. That means P times B. Well, that's exactly the original form. But now the real use of this is in getting the other guys. Let's cover up the P. What does the P equal? The P equals A divided by B. Here it is. And the last version of this, what B equals, well, simply do the same thing. Cover up the B, what's left? A over P. Okay, now, you can get all these different forms of the percent formula just by rearranging the original guy algebraically. But this is a nice quick little trick, and it works for simple formulas like this where there's one letter on the left and two on the right, and the A equals PB happens to fit this pattern. So if you remember this, make your triangle, put the T in it, and you have to know the original formula. The single A goes on top and the P and the B in the bottom, and then after that, whichever version you want, just cover up the P or cover up the B or cover up the A, and what's left is exactly what you should have. Well, that's a nice shortcut that we'll make use of as we go along in these problems. Okay, let's start looking at them, but I want to remind you once again that the key to this is identifying these three in the order we've given here. Identify the P, the percent, first, because it's easiest to see. You've got the percent sign, or it says the word percent. After that, you ask yourself, what is the number that I would have to know first, that occurred first, or was the original number in this problem? That's the base. Whatever's left is the amount. That's basically how you get the amount. It's the leftover. Okay, well, let's start looking at some of these guys. Here comes the first one. Okay, a student got 42 problems on exam correct. If this was a 75% score, how many problems were on the exam? Well, okay, you can identify this as a percent problem because you see it's got a percent here. And so the first thing we would identify is what the P is, and that's got to be the 75% because that has the percent sign. Okay, there's the P. We've identified that. Now, the next thing we do is go after the base. Well, the student got 42 problems on the exam correct. Trouble is, you couldn't get anything on the exam at all unless you had the exam to begin with. So the exam had to exist before the student took it. So what was the original or starting thing? Well, however many problems were on the exam, that had to be the base, because the base had to be there before the student took the exam. Well, notice the B here is not given. That's what we're solving for, so I'll put a little question mark after it here. Now, the only other thing left in the problem has got to be the amount, and this is, of course, the amount that the student got right. That's the 42 here. That happens to be the A. Okay, well, we've identified first the P. It has a percent sign with it. Then we took a look at the things that are left and asked which one of these did we have to know or that existed first? Well, the exam existed before the student took it, so the number of problems on the exam have to be the base. What the student got right has to be the amount that they got right. Okay, well now, we need to solve this. Let's remind you here that if we make that triangle, put the T in it, and put the basic formula in here, A on top and P and B on the bottom, we're solving for B here. So what is B equal in this problem? Well, cover up the B, and you see A over P. So that tells you that B equals A over P. It's a quick way to get it. Okay, so here we go. What's the A? It's 42, so the 42 goes upstairs. What's the P? 75%. Now remember, you've got to convert that to a fraction or a decimal. Since it's by itself in the denominator here, I'll make a decimal out of it. And now that you've got that, what you simply want to do is go grab your calculator. Now let me point out to you, if the student got 42 problems right on the exam, then the exam had to have more than that, so we better come up with a base that gives us more than 42 problems. Let's see what we end up with. Take the 42, we're going to divide that by the 0.75, and we end up with, well, hopefully if you did this, you got 56. And of course, don't forget, you've got to label them here. This is a word problem. So, what was the base? The number of problems on the test, 56 problems. Okay, well, let's get some more practice on this. Once you get the hang of it, this method works really nice for these percent problems. Okay, here's the next one. 108 employees at a company go to the gym at least once a week. If this is 30% of the employees, how many work at the company? Well, first off, we're going to identify the P, and we've got something with a percent on it here, 30%. So that's the P. It's given to us in the problem. Now, 108 employees go to the gym. We want to know how many people work at the company. Well, you've got to work at the company before you go to the gym. So the people that work at the company here has to be the base. We have to know that people are working at the company before we can say, well, they're company employees that go to the gym. We've got to know they're working at the company first, so there's the base. That means the A is the amount of those employees that do go to the gym. So this problem, once again, it's the base that we're trying to identify. And remember, of course, if we make our little triangle here and put our T inside of it, and you got to remember A, P, and B again. We're solving for base, so what's the B equal? Well, if you cover the B up, it equals A divided by P. The little triangle works good for getting you set up here. Now just put these values in. Again, the A goes upstairs, it's 108. And the P, we convert to a decimal, 0.3. You can put the 0 if you want, or just make it 0.3. But now, of course, what we need to do is go get that. Now, remember, here's the idea. Not everybody at the company goes to the gym. Only 30% of the folks do. So, the number of people we get working at the company better be a lot more than the 108. Let's see what we get here. 108, and we're going to divide it by the 0.3. And what'd you come up with? Okay, I did that. I came up with 360 people who work at the company. Okay, so there again, by identifying first the P, then the B, and the last guy's the A, these are pretty straightforward problems. Okay, here we go. Here's another one. A basketball team, let's get that correct. A basketball team scored 72 points. If 25% of their points came from three-point baskets, how many points did they get from three-point baskets? Okay, well again, this has got a percent, so you can identify this as a percent problem. That means we can use the A equals PB formula, but of course we've got to identify everybody first. Well, here's the 25%. It's got the percent sign, so that's obviously the P. Now, can we tell how many points they got from the three-point baskets if we don't know the total amount of points that they had? We've got to know everything they scored in the game, then we can figure out what part that is of the whole amount. So the first thing we need to know here, what they scored in the whole game, so this is the base, the 72, and how many they get from the three-point baskets? Well, this is going to be the A, the amount that they got from those. So this time the unknown is the A. We know the percent and the base. So again, making our favorite little triangle here. Here it comes. Put the T in it and the A on top and the P and the B in the bottom. This time we're solving for A. What's A equal? Well, it's just the main formula. You might have remembered that. Maybe didn't need to make the triangle. But A equals P times B right next to each other. Okay, well, here we go. What's the percent? 25. Now, that percent can be converted to either a decimal or a fraction. If you convert it to a fraction, remember our nice little relationship, the percent sign can always be traded in for over 100. Okay, well, since 25 will reduce into 100 real nice, I'm going to take this percent sign and trade it in for over 100 and write this thing as a fraction because it's going to be reducing real nice. So there's the P. The B is 72, and I'll make a fraction out of it since this first guy was a fraction. Okay, well, of course, the 25 over 100 reduces real nice. 25 goes once here and 4 times into 100. And we can reduce the 4 and the 72. 4 goes once here, and the 72, let's see, it goes once into 7. That leaves 3. 32, 4 times 8 is 32. So I think we've got 1 downstairs. So what's the A equal on here? Well, 1 times 18 is 18, so what did we get? We got 18 of those 3-point baskets. be sure again to label the answer on this. Here it is, 18 of those 3-point baskets. Okay, well, hopefully you're beginning to get the idea here again. Like I say, this works pretty nice, and the key is you can identify all the things. Here's another one. In a company with 560 employees, 35% go to the gym at least once a week. How many go to the gym? Well, this sounds very much like the problem we had just a little while ago, but we're solving for something different here. So watch what goes on. First again, you see somebody with a percent sign here, so you know this is a percent problem. And of course, it's the P that we want to identify first, so the P equals 35. Now, we've got a company with 560 employees. We want to know how many of these employees go to the gym. Well, you got to know how many people, you got to know they're working for the company first before you can figure out how many company folks go to the gym. So this base here, 560, has to be our starting value. We have to know you're working for the company before we know that you can go to the gym for the company. Okay, well, how many are going to the gym? That's the A. That's the amount we're trying to find. And of course, since the A is the thing we're solving for, that is the main formula. I don't think you need the triangle for this one. A equals P times B. And once again, I'll go ahead and use our little relationship, take the percent sign in and trade it in for over 100, because 35 over 100 we can do some reducing on, and then of course multiply by the base, 560, and I'll make a fraction out of it just because this guy's a fraction. Let's do some reducing. Well, the first thing, I can reduce 5 into both top and bottom here, can I? 5 goes into 35 7 times, and 5 goes into 100 20 times. Now, look at this. The 20 will reduce into 560. 20 goes once here, and it goes 28 times into 560. Okay, so what's the amount here? Well, we have 1 times 1 downstairs, so the answer is just what the upstairs is. What's 7 times 28? Well, 7 times 8 is 56, carry the 5. 2 times 7 is 14, and 5 is 19. So we come up with 196 employees, okay, that go to the gym. So again, remember to label your final answer, but again, by correctly identifying everybody, we are able to set this up really nice. Okay, well, here we are. Another problem like this. Notice it says it rained 7 of the 28 days in February. What percent of the days had rain? Now here's a problem where we're not given a percent. Okay, this would be the percent right here, but since they don't give it, I'll put the question mark here. That means that's the one that we've got to be able to figure out what it is in the problem. So we'll have to remember that we want to convert the final answer to a percent. Okay, well, before we can figure out the rest of this, we've got 7 and 28 here. Well, first thing we have to know, the original thing, is how many days in February. We've got to know all those 28 days before we can figure out which ones had rain on it. So the full 28 days in February is the base. We had to check all those days before we could figure out that there were 7 of them that had rain. So that means the A has to be the 7. Okay, well, let's set this up. Here again, we're going to use one of the forms of our percent formula. So here's my triangle with the T in it. And again, A, P, B. Now, in this one, we're solving for P. Cover up the P. What's the P equal? A over B. So that tells me exactly what form to use here. A over B. Okay. What's the A? It's 7. What's the B? It's 28. Well, let's see. This is nice. 7 reduces right into 28 4 times. So this is 1/4, which of course as a decimal equals 0.25, and as many of you probably already knew, as a percent was just 25% when we move that decimal place 2 points to the right. So 25% here, and of course we've labeled it with the percent sign. Okay, well, like I say, this percent formula works real nice with all of these. Let's look at another one. 650 people attended a concert. 338 of these were women. What percent were women? Well, again, you can tell this is a percent problem because they're talking about percents, but the percent was not given, so this is what we're solving for. But there's the first thing we identify. Now, we got to tell which one of these is the base and which one is the amount. And this is, of course, the problem with direct translation of regular word problems like this. Folks often get these guys backwards in direct translation, but here's the idea. You go after the base first. Well, you've got to have everybody at the concert before you can count how many of them are women, don't you? So you have to know how many are at the concert first. That means the 650 here has to be the base, and the 338 then has to be the amount. So once again, it's very simple to tell what the base and the amount have to be. Okay, well, again, let's make our triangle here. Here it comes. Okay, put our T inside of it. A, P, and B. You have to remember the main part of the formula. Now we're solving for P here. So what's P equal? Cover up the P. It equals A over B. Okay, what's the amount then? 338. What was the base? 650. Well, we might be able to reduce this a little bit, but this is a good one again to go get your calculator on. Let's do that. Take the 338 and then turn around and divide that by the 650, and we end up with, I get 0.52. Move the decimal point 2 places. That means I could just write this as 52%. So how many of the people at the concert were women? 52%. Okay. Let's see. Here we go. Talking about rainfall. Normal rainfall is 18 inches. This year we had 22.5. What percent of normal is this? Well, you can tell it's a percent problem again because you see the word percent. And like we've had in some of the recent problems, the percent is missing, so we're going to be solving for that. Now, this year we had 22.5 inches. Normal rainfall, which means all the previous years, okay, the normal or average is 18 inches. Well, we had to know that average first. It occurred earlier. We knew that before what happened this year. So that means this is the base right here. What occurred earlier, and now what we have more recently here is the amount of 22.5. Well, notice the amount is larger than the base. Our percent better turn out to be more than 100 here. Let's turn around and set this problem up again. Here comes our triangle as usual. Okay, with the T in it, A, P, and B. We're solving for P once again, so P equals, cover up the P, A divided by B. So here we go. What have we got? 22.5 is the amount over 18. Okay, well, again, let's get our calculator to see what we've got here. 22.5. Remember, we said we better get ourselves more than 100% here. And what do I come up with? 1.25, which, of course, when we move the decimal point 2 places to the right, gives me 125%. So the rainfall this year was 125% of normal. Okay, here we've got an example. It says last year 16,500 people attended their city's free concerts. This year the attendance decreased by 3%. How many people attended this year? Well, now, it's a little twist in this one. decreased by 3%. Okay, here's the safest way of being able to work this one. If it was exactly the same as last year, it would have been 100%. 100% is the reference. Well, if we've decreased by 3%, then that means it's 3% below 100%. That means it's 97% of last year. Now, we'll see other ways of being able to solve this. Most everything we're showing you here in this whole course, there's more than one way to do it. And, of course, any workable way is fine. I'm just going to be generally showing you one or maybe two, but not every possible way. Okay, well, then that means this year's attendance is 97% of last year. Okay, well, how many people attended this year? Well, last year there were 16,000. Remember, the base is always the earlier amount, and last year was earlier than this year, so the base has to be 16,500. That means how many people attended this year? This is the A, and we don't know it, so we had the base, 97%. We had to do this one little conversion here, decrease by 3%, means we've got 97% of last year. And we'll show you other ways of handling a guy like this in the future. This is not the only way by any means. But anyway, doing it here, we're solving for A. A is the main part of the formula. A equals P times B, so I don't think you need the triangle for this. The percent, 0.97. I'm going to convert the percent to a decimal. Here it is, 0.97, and the base, 16,500. Okay, well, the amount this year, since it went down, should be somewhat less than this. 3% is not a whole lot. But let's get our calculator out and take 0.97 times the 16,500, and let's see what we come up with. I did it, and I came up with 16,005. And so how many people attended this year? 16,005. And don't forget again, label it. These are people. Well, for the last thing we're doing here, I mentioned to you that this also works with the direct translation problems. Let me point this out to you right here. Here's one of the direct translation guys we did. And we can solve this for the A equals PB formula, get exactly the same answer. Now remember, simple guys like this, you can do them direct translation, but I want to point out to you that they also work with the A equals PB, and you could use the A equals PB with everything. First off, here's a guy with a percent. So that's definitely the P value right there. Now, here's the thing in these simple problems. What follows the word of is always going to be the base. The base follows the word of, and it's not given here, so in this particular problem, it's the base that we're solving for. Well, the guy that's left is the amount. He's usually close to the is, one side or the other. So here's the A. Okay, well, in this particular problem, we're solving for the base, so we can use our triangle again here with the T in it. A equals P times B. We're solving for B equals, cover up the B equals A over P. The A is 28. The P, now remember, we've got to convert this to a decimal or a fraction. Let's go ahead and convert it to a decimal. I put a decimal point here and just move it 2 places back to the left. We get 3.5. You could put the 0 if you wanted, but you don't have to. Now, let's turn around and simply do this division. We got 28 divided by 3.5 comes out to be, right on the button, the same answer we got when we did this with direct translation. We end up, or the base is the number 8. Okay, well, the percent formula here, A equals P times B, works with all these percent problems, even the simple ones that you can do with direct translation, but The more wordy problems that we've been working through, direct translation often gets those backwards, so the percent formula is a much better way to go.